Welcome to an example of where we're trying to find the equation of a parabola with its vertex at the origin and its directrix. So let me begin by drawing what we're talking about. I think that'll be helpful. So here it is. Well, here, I'll do it right here. Okay, so we've got an axis system, and we have this parabola is at the vertex at the origin. You know what? I better pause right there. Let me draw for you the four. This is what you want to definitely have for yourself, is you want to know or have in your notes these four directions. Whoops, that's a funny line. For the parabola. 1, 2, 3, and 4 here. Okay, so how do parabola equations go? Well, first off, you can have y squared, whoops, I'm on the wrong tool there. Y squared is positive for ax, or you could have y squared is negative for x. Positive 4ax will go to the right, negative 4ax will go to the left. And then down here, you could have x squared is positive for a y, that will go upwards. And x squared is negative for a y, that will go downwards. So notice that the direction of the parabola, like this one's going to the right, is the first power letter, right? Positive x to the first power to the right. Over here, negative x to the first power goes to the left, negative x-axis. See how the first power letter, not the second, not y squared. Down here, same thing. Go to the first power. That's the unique mark of a parabola. A parabola, in particular, has one letter squared, the other not. Either x is squared, y is not, or y is squared, x is not. And the key is really in the first power letter. This guy tells you the direction. Do you see that? The first power letter tells you the direction that the parabola goes. That's the key. You want to have this in your notes on the next exam and when you're doing your parabola homework. See, positive y, up it goes, positive y direction. This one, negative y, down it goes, negative y-axis direction. Okay, so with that in mind, oh, and we need a little bit more than that in mind. Let me give you one more key fact. Now, what's this A thing? The A is right there. It's inside of the parabola. It's how far from the center, from what's called the vertex, the center, to the focus point. It's how far to the focus point. So this one's at negative a, because it's back from the origin, right? Negative a there. This one is up, positive a, from the origin, from the vertex. And this one is down, negative a, down from the vertex. So A is the distance. This is what you got to be really, in fact, let me write it up top so it's just super clear. This is the part people get confused about. A is the distance from the center, or the vertex they call it, to the focus point. And then let me add a new note. Now here's the new piece of the puzzle. Backwards to the directrix, and that's what we're going to need on this problem. Backwards to the directrix. What am I talking about? Well, there's this line which we don't, it's a dotted line. It's not, we don't really see it. It's not visually there on the graph, but it's there in force. Kind of like we don't see the wind, but it has a force and an effect. We don't see magnetism or electricity, but we feel its effects, right? It's real. It's part of the real world. We don't see the atoms. There's all kinds of things we don't see with our naked eyes that are affecting our lives. And Directrix line is one of those. Let me put it right here. the directrix line, it's back negative a. It's the opposite direction. So this one, it would be here. This would be sitting at negative a. It's a line. It's a dotted line because a dotted line means it's not going to really show up on the graph. This one's at negative a. And this one's up here at positive a. So do you see the directrix line? That's called the directrix line. So let me get rid of all this direction. That word might confuse you with the directrix word. So let me get rid of that. Okay, yeah, this line is called the directrix line. Okay, so I'll put it right here. Directrix line. This one, directrix. It directs the graph, so to speak. So what about that directrix line? It's exactly the same distance. In other words, the center of the parabola is right in the middle of the directrix line on one side and the focus on the other. Does that make sense? Same distance to the focus as backwards to the directrix. So again, the parabola, the center of the parabola right here, the center of the parabola, called the vertex. Same distance to the focus and backwards to the directrix. Always the same distance. Forwards, so the focus point is always inside the branch, and the directrix line is behind the branch. Same thing here. Here's the parabola. Focus point is inside. That distance, same distance backwards to the directrix line, which is always behind the back of the parabola, directing it. So it's like the puppeteer directing the puppet, right? He's holding the strings. There's a good analogy. Directing the parabola from the back, from behind. You can't see him, but he's calling the shots and pulling the strings. Well, that same thing here. Look at this parabola. Here's the focus point inside the parabola, and the directrix line behind it, directing it. Same distance back as forward. Same distance to the focus point and backwards to the directrix point, meaning the center of the vertex is right in the center of the directrix line and the focus point. Okay, so have these on your notes for the next exam for sure. All right, so how's that going to help us? Well, let's go to the graph now. They're telling us that the directrix is at x equals 1/28. So I'm just going to put it right here. Boom. That's the directrix. Let me get rid of this word's coming out too far. Here, I want to leave this graph clear for you. There's the directrix for that one. Anyway, this right here is the directrix point. I'm going to call this the point 1/28. It's really a small fraction. X equals 1. It's on the x-axis, right? Over at 1/28. X equals 1/28. All right, so what? Well, and they told me the vertex is at the origin. So the center of this parabola is right here. Center's right there. And the directrix line is right here. Right? It's going through the x-axis at 1/28 over. Right? X equals 1/20. That's a vertical. The directrix is a line. The focus is a point, and the directrix is a line, a dotted line, so you don't really see it on the graph in the end. It's a dotted line going through the x-axis at x equals over 1/28. So it's that dotted line. Okay, great. And the center of the focus is the origin. The center of the parabola, called the vertex, is at the origin, they told me. Okay, great. So what? So that means, which way does the parabola open? That's always the key, is to know, does that thing go right, left, up, or down? Well, notice that whenever you have a vertical dotted directrix line, the directrix goes away from it the opposite direction, right? Remember again, it's behind the parabola. So here's a dotted line, and the parabola's going this way, away from it. Or here's a dotted line, the parabola's going this way, away from it. So here's a dotted line. Which way is the parabola going? This way, away from it, right? Always. Now, you might get on your example, the one that you get, it's going to randomize it, and it's good to practice more than one of these so you get really good at this. They might give you one, I don't know, but you might get one that is centered here at the origin, and you might get one that, I don't know, it's up here. They might tell you y equals 1/10 or whatever, you know, and that'll be your directrix line. If that would be the case, then your parabola would go down, wouldn't it? Because again, the directrix line, that would be on the y-axis, is always behind the parabola, behind it. And then the focus point will be inside. So the focus point will be like there. If they'd given you y equals 1/10 as your directrix line, you might get that one on the randomness. I got x equals 1/28 for my directrix line, so my parabola goes to the left away from that. And the focus point is going to be right here. And remember, this distance and this distance are the same, aren't they? So if this is positive 1/28, this must be minus 1/28. That's where the focus point, that's the A, in other words. That's the A. This is the focus point, right? Did you catch that in my diagrams over here, right? A is the distance, both backwards to the directrix line and forward to the focus point, right? A, right? The center of the parabola is right in the center of the focus point and the directrix line. So if this is positive 1/28, this has got to be negative 1/28, and that's A. A is the distance from the center to the focus point and backwards to the directrix. Okay, great. So what? Well, now we basically got it. So in other words, which of these four, is it this one, this one, this one, or this one? Well, it's this one, right? It's branching to the left. So it's this one. So let me circle it. Right there and bring it on down. So my equation is y squared, I'm grabbing this equation, right, equals minus 4ax. That's our equation. And what's the A? It says it right here, 1/28. Now, you don't need to, I know it's a little confusing. You might say, well, yeah, but you got to plug in A as negative. No, when I give you these formulas, I hope I'm not being confusing. When I give you these formulas, I've already done the negative. So technically, these formulas don't have a negative. This will be negative, and so that'll make it in the end negative. I hope that wasn't confusing. So it just know this. In the end, anytime the parabola goes left, it's got to be negative. Right, it's got to be positive. Up, it's got to be positive. Down, it's got to be negative. When all is said and done. So I'm trying to make it easier by showing that to you. So you can plug in the negative here, or you could say, look, I'm gonna plug in the negative here. Great, whatever. Same thing either way. Just one negative though. So okay, now how do you simplify that? So this is 4 over 1. So that's going to be negative 4 over 28x, and so that is minus 1/7 x, right? Just reduces 4 into 28 7 times. So y squared is minus 1/7 x. That would be our equation. So maybe I should just write right here. That is our equation. Oops, that's not what I wanted. All right, are we good there? Is that making good sense? So then I give you the other option, but I won't finish that one up. So there we go. It's all about understanding these 4 setups. Really, you need to spend time on those 4 setups, being super clear on what they mean. So again, the equations that go with the different pictures. And the A is the same distance forward or backwards to the directrix line or the focus point. So maybe I will finish up this other one. So let me erase this right here. So what if I was to finish up this other version? Let me do this other version down here. So y equals 1/10. This is up here at y equals 1/10. So the focus point would be right here. A equals negative 1/10. That would be the focus point, right? Inside, negative 1/10. So which setup are we going to use? Going down, this setup, which means x squared is minus 4ay. So you just grab that and you go, oh, okay, x squared is minus 4ay. And now remember, it's just negative. You don't need to plug in another negative. A is 1/10. We've already done the negative. So that would be x squared is negative 4/10 y. Reduce that, negative 2/5 y, right? Divide by 2, top and bottom there. Negative 2/5 y. That would be that equation. So you're seeing those differences. It's all about, for parabolas, knowing these four, using them, putting in your notes and knowing how they work.